Okay, this video will help you with the homework problems that you had some trouble with. I had a couple of requests, so I'll start with 15, which is y equals sine of xy. I know that we learned logarithmic yesterday. You don't have to use logarithmic unless you have something with an x to an x. When you have an x to an x, that's when you have to use logarithmic. So you don't need to use it here. This section has multiple different things going on. And when you take the derivative of this, what we're really practicing is kind of the chain rule, because the derivative of sine is cosine. We don't do anything. We just, the cosine of xy. Sine of xy's derivative is cosine xy. Then we use our chain rule, parentheses. And that should be derivative of the first times the second plus derivative of the second times the first. When you do the second, you leave it alone. You don't do anything with it. So derivative of the first is 1 times the second, which is y, because you didn't do anything to it. Derivative of the second is dy dx, and times the first by itself. You should put this in the front, or you should just rewrite it as this. I'll just distribute it, I think. Y cosine of xy plus, I guess dy dx, x cosine xy. Now, when I want to solve for dy dx, I have to move those all to the same side. So it's going to be dy dx minus dy dx x cosine xy equals y cosine xy. And we will factor out the dy dx. Make sure you're comfortable with that. That's definitely going to happen. Factor out the dy dx just like it's a normal variable that we're trying to solve. So again, we're trying to solve for this. This is what we're trying to solve for. And now we'll have just y cosine xy all divided by that quantity, because we're dividing by that on both sides. I'll just put a scribble there. I don't know if we need the extra parentheses, but I'm a big fan. Okay, so that was 15. Hopefully that's helpful. I had some requests for 17, I think, but not a ton of people asked for it. So I'm going to skip it because it's a similar problem. Make sure that if you are doing that problem, you don't need logarithmic. You could. I also see 41 and 43 coming up. Those I think get a little messy, but they're doable. Tangent of x plus y, that one came out a little strange. So 31, I'm just going to kind of like table that for a second. I tried to do this video before and it got deleted. That was really annoying. But let me make sure I can get to a couple of the ones that I think are pretty straightforward, and we can clear these up pretty quick. 67 is y equals x to the 2 over x. What did we say about variable to a variable? You can't do it unless you do logarithmic differentiation. So we're going to ln both sides. I just took the ln of both sides. We're going to use the logarithm properties, not the power rule, to bring the 2 over x down. And then we're going to take the derivative of both sides. So when we take the derivative of the left side, we get 1 over y dy dx, because the derivative of ln of x is 1 over x, so the derivative of ln of y is 1 over y, but it's dy dx because, as you probably know, we are taking the derivative with respect to x. Now, we could have taken the derivative with respect to y, and this would have been coming out easy, and this would have had a little bit more, going on, I guess you could say. All right, so let's derive this part. So now this is a product rule. It is. So we could probably just think of this as 2x to the negative 1. So the derivative of the first would be negative 2x to the negative 2 times the second. which is ln of x, plus the derivative of the second, which is 1 over x, times the first. When I do a product rule, I do 4 sets of parentheses. I don't want to mess anything up. And extra parentheses, the chances that an extra parenthesis messes you up is so low, and the chances that a missed parenthesis messes you up is pretty high. So I just use extra parentheses, and I lower my chances of a mistake pretty solidly. So dy dx equals, and we're going to multiply the y on both sides. So everything's going to multiply by y. So y on both sides. And then we'll have just this times y. So the best way to write it would be negative 2x squared. I'll just put the y here. Ln of x plus 2 over x squared. And that should be good. I know that the answer in the back could have changed out the x, so I'm just going to take a quick peek to see if it did. Hopefully, if I pause this, it will come back. Okay, so what they have here is, let's see, this is 67? Yeah, 67, I believe. So looking for it right now, sorry. It looks like they have this, and then they just put back in the y, I believe. So x to the 2 over x. So they put this back in as x to the 2 over x. And then what they do is they probably simplify a little bit. They love to simplify. We don't love to simplify, and that's usually okay. So really, that's all that's happening there, is that they're just simplifying. If you'd like, we can kind of go through that, because we don't often do it, but it'd be good to do it. It'd be good to do it this time. So that means that let's just go ahead and distribute this right now. So what that will give us is, if we, what was that, x to the, so this is actually x to the 2 over x, I think. X to the 2 over x. So if that's x to the 2 over x, then we need to simply distribute it. So I guess what we'll have is negative 2x squared. I think I could add these exponents, but it just seems a little odd to do that. Sorry here. Just making sure that we are charging. Yeah, my battery's getting low. Geez, I think I could add them, but let's see what they did in the back if they added them. Yeah, it looks like they did, I think. So we're going to add these exponents because we are keep the base, add the exponents. So this would be now 2x to the negative 2, right? So we could actually do this as 2x to the 2 over x minus 2. I think that's going to match. I'm trying to take a quick look. I'm looking at my other screen. So 2x, okay, so they took out 2x. They took out 2x, and then they took out 2 over x minus 2. So I guess that's this, right? 2 over x minus 2. Okay, these terms are going to switch. This is now going to be 1. And now this is going to be tricky. It's going to be minus ln of x, sure, because that's this part, right? And then how do we get this to be correct? When we take that, we'll have, okay, so we'll have negative 2x to the, we need x to the 4th, I think, or something like that. Let's see what they have. X to the 4th. I hate it. I must have made a mistake with an exponent. Apparently, this should be a minus, because if this was a minus, I think we were in good shape if I swapped it. So I'll have to go back and see why that is. So we have a little issue here, but it's a minor issue. I think as far as the calculus, the standpoint of knowing that if you have a variable to use logarithmic, that's the most important thing I want you to understand, to ln both sides. I want you to remember the log property. I want you to remember to put your parentheses, multiply by your y, and put it back in. Those are the big things. I will either cut this or put a comment below in the description later. Okay, so then there were some like AP questions towards the end that were like I don't think they were anyone's favorite really. But I think if you get 67, 69, 71 should be both pretty acceptable from there. I think the first one was 84. Some people were, I don't think you get the answer to that, so let's just take a quick look at it. This one's x ln of y equals 2. So that means that the derivative, so these are the things we want to focus on, breaking this into a product, right? Derivative of the first times the second. But it's left alone. There's no dy dx there. Plus the derivative of the second, which normally would be 1 over y, because it would normally be ln of x, 1 over x. Now it's ln of y, 1 over y, but we have to have dy dx. Derivative of the second times the first. Probably a little overkill there, but it works. Equals 0. Okay, equals 0. Okay, so to get this alone, right, and this is where we want to be very fluent. Subtracting ln of y. So we now have subtracted ln of y from both sides. And we can divide by x over y. Would you agree? This x can kind of be here, it's multiplication, instead of there. Just put it there. And if we divide this by x over y, we have a complex fraction. We'll have to deal with that. But we should have dy dx. We could also multiply. That's not a negative. Sorry, that's not a negative. We're dividing by x over y. We could also multiply by y and divide by x, and that's what we're going to do in a second. So we're going to have this, and then I guess over 1 times y over x. So you line up with negative y ln y over x. That should be dy dx. Okay, let's see. Yeah, very good. So that was there. So that's kind of nice. This is an AP like type question. This is sort of the type of simplification we're looking for, right? Like we have this here, and you can kind of see that it's not horrible. And now you got to get your answer to match it. And this is a good question. Not too hard, not too easy, I would say. So just keep that in mind. Something to think about. Also, we had 86 and 87 were some questions. I believe that 86 would be good to talk about because I have not, I think maybe once, but if you have y and you take its derivative, you have y prime. You take that derivative, it's y double prime. You can take a derivative twice. So what that means is if you have y and you take its derivative, that's normally written as dy dx. If you're taking it with respect to x, this is kind of like a caveat, right? So as you take that with respect to x, imagine you take that with respect to x again. Well, the notation for that is pretty weird, but the d is kind of squared. It's d squared y over dx squared. Look at that, because I don't think I taught that to one of my classes, like my first year, the notation of that. And I paid for it because I just kept writing y prime. I kept writing y prime, y double prime. And I think it might have been on a quiz or something. And then I had to give them points back. Or it might have been on a practice test. Who knows? I was shocked that they hadn't gotten it. So that's the notation for that. So y, dy dx, d squared oy over dx squared. It just means y double prime. Take the derivative twice. So that's what we're going to need to do here. And I am glad that I got this question. So x squared plus y squared equals 100. You'll probably be fine. So make sure you're flagging this. This is important because this is in a video somewhere. I remember having this, but I don't know that we have gotten there yet. The second derivative. So as we solve this, and assuming we're okay with solving this, and this is where I often make a mistake, we should be there, right? We should have this. Now what they told us was that the point was 6, 8. So since they told us the point was 6, 8, I could actually put in the 6 and the 8 here. So negative 6 over 8, which is negative 3/4, right? And that'd be a good start. That's dy dx. However, they didn't ask us for dy dx. They asked us for the second derivative. So what are we going to do? Well, we're going to take this right here, dy dx, and we're going to take its derivative. So d squared y over dx squared. That's me just taking the derivative of that. Deriving d dx. I'm going to take the derivative of the other side. That is a quotient rule. Derivative of the top. Should we do different colors? Probably. Derivative of the top times the bottom minus derivative of the bottom times the top. Derivative of the top, just a negative 1, times the bottom minus the derivative of the bottom times the top, which actually has that negative again, so that's a plus x now, all over the bottom squared. So that's going to be, I mean, there's not a lot of simplifying there, right? But here's the deal. You could either take dy dx and plug this back in. That's what I used to do all the time. But when they give you a point, you know that this is the slope finder, and you've already found the slope. So you can put that right back in. So you can actually be dealing with a lot nicer equation because it gave you something to plug in. So this is, this is this. So we have negative y plus x times negative 3 over 4 all over y squared. And now we can plug in numbers, right? Remember those numbers? What were they? 6, 8? Good, 6, 8. So let's remember it's 6, 8. That's x, that's y. Let's plug them in. So negative 8 plus 6 times the negative 3/4 all over 64. Okay, and again, back to simplifying. Now you have a better understanding of what they're looking for when you are needing to simplify. It's a multiple choice question. We have to simplify it. It's a fraction and a fraction. So, obviously I must have been on to something when I said no fraction and a fraction. Let's just get a common denominator, I guess. So 8 times 4 is 32. So we have negative 50 over 4 over 64. Okay, that's good. Negative 54 over 4 over 64. So what does that mean? We get the 64 in the denominator. Negative 50 over 4 times 1 over 64. So 64 times 4. So 64 times 4. This is the type of stuff you need without a calculator. And I think I have kind of been helping you get there. So that's where I'm at. And then when I take half of that, it's negative 25 over 128. And that is the answer. We had that. Very good, very good, very good. I do want to just make a quick comment on 87B. It says, where do we have a vertical tangent line? Well, a horizontal tangent line was 0 over something. You set the top to 0. Set top equals 0. Find x. So a vertical tangent line is going to be, you guessed it, set bottom equal to 0. Find x. So you're finding the x that makes the bottom of the slope, right? The bottom 0. So that's important. That's 87B. That might catch you. Okay, I got to wrap it up. This is longer than it should be. I will see you in the next video. Peace.